Hey, thank you very much, and thank you for joining this session. And let's let's start. I I don't see pretty many of you, but before starting, I want you to reflect over one question. How many of you are still relying on a classic and traditional antivirus to protect your personal but also professional assets, such as your laptops, your computers, your mobile phones, just for your own self-reflection? Um, and are you confident within this decision? Because there are a lot of attack vectors that target those systems, those defensive mechanisms in order to bypass. And today we will be talking about a very interesting one, how we can bypass antivirus using a little bad USB device, which is actually um a normal USB, but inside it's actually an Arduino microchip that runs some malicious code, and we'll see it how we can do it a little bit later. But let's start with the beginning. Some words about myself. I have some certifications, including OSCA, was founder of the Zero Tech Security, which is a cybersecurity company. And we are providing security and pen testing services for our clients that are located all over the globe. Also, I'm a trainer for multiple entities, both within private and public sector, and speaker at multiple conferences, such as besides Cybersecurity Congress for us, DevCamp, and so on and so forth. And also, when I find some free time, I write on media too. So the agenda for today will be the following. We have the AMSI bypass techniques, execution policy bypass techniques, payload runner development in order to see how we can have a fileless payload to run directly into the memory using the BadUSB, because we want to be stealthy. We want to leave no trace. So we'll run everything within the memory. And how can we deploy all the above items on a little bit USB, and a demo, and also some prevention mechanism to take into consideration. Okay, so we have the following scenario. Bob. Bob is a good pal. He goes to smoke in the uh, from his office to take a break, go smoking, and found a little USB device in that place where he goes to smoke. And what he thinks, Bob's will bring the BadUSB um, or the actual USB to the office, because our users are curious, right? You may know this aspect. Users, people in general, are curious, so they find something on the ground. Usually they'll test to see what's on this USB, what's on this disk. I had a lot of scenarios where curiosity of people went far beyond the security measures that we had in place. But it's another story. So Bob introduces the BadUSB to into his computer. What happens is the following. We have an attacker that is connected to Bob's computer, but Bob firstly has Windows Defender enabled, fully updated, uh, and with cloud protection, with real-time protection on, so it's fully running. And also Bob account is a low privileged account, so it should not have permissions to run some scripts or unsigned scripts. And also, we have a global wide policy within the company that disallows to have removable media storage. So uh, then basically, what did that USB do in order to have this attack successful with all those measures in place? Actually, we'll see during the next slides what was the sequence of attacks, because there are more techniques than just one embedded into this payload that we will be creating. But the first one is the AMSI bypass. What is this AMSI? It stands for Anti-Malware Scanning Interface, and think about AMSI as somebody staying between what scripts, what PowerShell scripts you are running on Windows, and the antivirus product that you have on your Windows. By default, Windows has the Windows Defender as a default antivirus product. But have you wondered ever why you cannot have two antivirus solutions in the same time? That's because of the AMSI. Because, as we mentioned earlier, it is the interface between the antivirus product and the scripts that we are running on the Windows machine. And after AMSI goes, okay, you can run that, you can use that script. Basically, just only after that you can use the PowerShell, you can use that VFB script, and yeah, you can run it. So it's is the main responsible for running the checks on the scripts. If we bypass the AMSI, we'll have no detection in place for the scripts that we run. So to do that, we will be taking a look over the function that is being used to scan those PowerShell scripts. That is AMSI scan buffer function that is loaded from AMSI.dll library. So what will be our purpose here? It is basically to patch the AMSI scan buffer function within the AMSI.dll library. So to manipulate it in order to return the same result every time. And how can we do that? Basically, the first step, as you can see here, something is pretty strange, right? We have two different languages, programming languages. We have the C# and the PowerShell. Basically, here, three functions were defined. So get proc address, load library, and virtual protect, which are basically Microsoft API functions, native API functions that has been defined within PowerShell. And we use add type within PowerShell to convert the C# functions to PowerShell script. And then using the load library, we'll load the AMSI.dll. Remember, we will play with the AMSI scan buffer function, and we need the AMSI.dll library in order to manipulate that function. And we'll get the exact memory address of the AMSI scan buffer function, and we'll use the virtual protect to, as you can see here at the third step, to make it writable. So in order to patch it. And next we will build in memory directly the return value of the AMSI scan buffer function. What is this value? We'll see during the next slide. It's pretty important although you don't need to remember it, you don't need to remember it uh, like this. Basically, I'll show you where you can get this value from, this patching value. Then, using a Marshall copy technique, we can do the replacement of the function with the memory, with the return value that we have built at step 4. And okay, returning to the value, why this one? If we take a look over the AMSI scan buffer function, it's Microsoft official documentation. It says, if this function succeeds, it returns s underscore OK. Otherwise, it returns an h-result error code. But the problem here with Microsoft is the following. They didn't mention that if the function returns an h-result error code, all the scripts will be run regardless of their malware status. So if we manipulate the function, the AMSI scan buffer function, to return an h-result error code, we can run any scripts. We can run any scripts regardless if they are malicious or not malicious. And as you may assume, this value that, if we go a slide back, if we used to patch the return value of the AMSI scan buffer, this value is actually an h-result error code, and it is the one or more arguments are invalid for the h-result code. And those values can be taken also from Microsoft official documentation, so it's all over the internet. Now we have a payload that is almost final. What we need here to do some magic, and it looks better. So we use obfuscation to make our payload more undetectable. Let's call it like this, using the invoke obfuscation from PowerShell, which is a common obfuscation tool. And basically, you can see that the values within the C# code has not been obfuscated. And you should not obfuscate that code, because then the add type will not convert it correctly back to PowerShell. So don't touch really that code when you obfuscate. Okay, next, execution policy bypass. As you may remember, Bob had a low privilege account that doesn't allow you to run PowerShell scripts, unrestricted PowerShell scripts. As you can see, this error is very, very common. You may have run into this error. Script blah 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 cannot be loaded because running scripts is disabled on this device. You may have run into this error. It's very common, and this one is the execution policy. Execution policy dictates if our users are allowed to run unsigned and untrusted PowerShell scripts on their devices. And what we have here as a bypass is the following. It's set minus execution policy unrestricted minus scope current user. Let's explain. So set execution policy is a native function within PowerShell, so it comes by default, and unrestricted is the value that will set the execution policy, and the scope of this execution policy, of this unrestricted execution policy, is the current user, which is Bob. And you may wonder, why is this allowed? Basically, it is allowed, so this execution policy bypass, it is allowed because it's not really a vulnerability, but it's a feature. It's a feature. We have uh, discussed with Microsoft about this problem, and they said it's supposed to be like this. So it's supposed to be like this, I assume, and it's a feature. It's a good feature, right? Okay, nothing fancy, just that one line code. So nothing really fancy there. Okay, next. We'll need something to have files into the memory, right? To inject directly into the memory. For that, we'll use a payload runner. And let's go over the details how to build a payload runner. Firstly, we'll have the lookup function, which is defined to search for assembly references within the memory. We'll not go into much details because we almost run out of time for this one. Then we have the getDelegateType function, which is used to set some argument types like integer, pointers, and so on. Why we need this one? We need this function because PowerShell doesn't know about pointers, doesn't know about C# specific argument types. So we'll use the getDelegateType in order to convert some parameters to C# parameters, such as pointers or integer or things of the nature. And then here we have the buffer, not the buffer, but the shellcode. But firstly, before injecting the shellcode, we need to allocate the memory, the needed memory within the device. Here was allocated something like 3000 bytes, and the shellcode was 2000 and half, basically. So it was well enough for our shellcode. And we can use something like MSV Venom with Windows Meterpreter, reverse TCP, plain text reverse TCP, which should be caught by all the antivirus vendors out there because it's pretty straightforward. But in our case, it will not be. So then we paste the payload that we generated into the file, not the file, but the script that we use, and using a Marshall copy, we'll inject the shellcode into the memory that we just allocated during the last slide. And as you can see here, we call the createThread function within kernel32.dll in order to execute this this memory space that contains the shellcode. And we should have now a shellcode, a reverse shell. But firstly, let's see how we can put everything together on this little device right here. So this one, it's basically a simulation of a keyboard and a mouse. It contains an Arduino microchip in it, and you can program using keyboard.hash and mouse.hash libraries. You can program to simulate the actions that somebody would do if they press a key on a keyboard or if they press a mouse button. So it can simulate those actions in a lightning fast way to do it. And how we can develop payloads on it, there are two main ways. Firstly, if you are comfortable with C++, you can use bgspark script, which is basically the Arduino programming language with its libraries. But if you are lazy and you need something very, very simple, you can use the Ducky scripts. What are those Ducky scripts? I think most of you heard about rubber duckies. And ducky script is the programming language used with rubber duckies. And it's very, very simple, and you can use something like Duckwino on GitHub in order to convert from ducky script to Arduino script. And it's pretty simple like this. So everything that you type after the string, it will type by your BadUSB on the on the device that it targets. You have delays, you can have comments within the scripts. Repeat X is basically a loop that repeats the last command X number of times. And you have also special keys, and this is very important. So if you have enter on your keyboard, then you need to insert enter within your payload, like you see here. You need to type those special keys. You need to write them within your payload as they are on the keyboard, on the actual keyboard. Guy is for the Windows key, and mouse underscore move X and I to move the pointer of the mouse to the following coordinations. And we have L mouse, R mouse, and M mouse, which stands for the mouse buttons, left mouse, right mouse, and middle mouse. And that's basically it, most of it. And let's get to the good part here with the demo. Let's see if I find it here, but firstly let me check the chat if there are. Okay, I think the questions will be the last. Okay, and we have here the demo. So as you can see, we have here the machine that we target with real-time protection on, cloud delivered protection on, and we insert a BadUSB, and the BadUSB will open a PowerShell, will type the scripts here, the payloads. As you can see, it's one-on-one with what we discussed on the slides. And basically you can see here the value, and you can manipulate the BadUSB to write with sleeps, for example, if the target machine is very slow. But for the purpose of this demo, I put sleep to be very to sleep a lot. And here is the session that got triggered. As you can see here, Metapretan session to open from the after the I put it on pause for now. After the create thread is being called on the allocated memory space, and here we should have a shell, a direct shell, and here we are with the direct shell. And the scary thing about this one is that not only we have a shell, but we can load mimikets. Having a Metapreter, we can load mimikets within the memory with Windows Defender fully updated and running in the background, as you can see here. Okay. Don't worry if you didn't take any photos or any notes. We'll have basically you have the presentation with all the payloads included. Okay, so let's talk a little bit defensive. How can we protect against those attacks? Firstly, cut PowerShell for all the end users that we have, and not through execution policy, but through group policies within Active Directory, access control lists on the physical USB ports with allowed devices and allowed manufacturers. Yes, I know this can be spoofed, can be bypassed, but at least it reduce the attack surface. and also shift a little bit the perspective between relying on traditional antivirus to have something more advanced in place, like an ADR. And of course, security awareness for our users is one core principle, right? Some research and statistics. Basically, we reported it to Microsoft. It's not considering this worth their attention. They said that it requires some social engineering attempts. It requires physical intrusion, so it's not in scope. And okay, so this is a presentation about it. Um, then basically it was tested on 20 antivirus vendors, free trials and free versions. 7 from 20 spawned directly a Meterpreter reverse shell with mimikets allowed to be loaded into the memory. 9 from 20 spawned a normal reverse shell, and 4 from 20 blocked totally the attempt. And I think we are done. We are at the end of our presentation. Q&A, if you have any questions.
Are there any questions from the audience? No? I do have one remote question, Christian. The question is, do you have any recommendations for further research in this area, sort of focusing on preventing common exploits against default configuration on corporate or enterprise systems? So if you can recommend just some research in this space and examples of similar exploits.
Yes. So basically, WASP is it's a good directory of resources that you can use for references as your reference for implementing defensive controls about against those security misconfigurations. Yeah, I think that's mostly it. And also, there are a lot of frameworks like NIST and things of that nature that provides you guidelines about protecting against some exploits and common misconfigurations.
Awesome. Thank you very much. Last chance for any questions? Oh, one question.
Yes, please.
Yeah, so I was curious about that AMSI bypass, and Microsoft said that did they say that was a feature, or that there's some justification for that?
For the MSI bypass, no, they accepted it, but they considered it that it's not a security basically issue, because you require physical access and social engineering. And for example, look, for your reference, when you have a pen test or when you have a red team assessment, if they are running Windows Defender, you can just copy paste the MSI bypass payload from this presentation within the PowerShell of the target, and it will bypass the MSI without even a BadUSB. But if you try to create a file with the MSI bypass, it will be detected by the antivirus. So you need to have that copy-paste technique directly into the PowerShell, and it will not be able to detect it.
So you already need to have access to implement that.
Yes, initial access, or you can embed it everything on a BadUSB and just deploy it in parking lots.
Awesome. Thank you very much, Christian.
Thank you. Thank you very much. Thank you. Have a good day.